OSI explains how network communication works through a 7-layer model. Here we see how those 7 layers compare with the TCP/IP model.
Layer number 7, or the application layer, provides programs with access to network services. This layer supports application and end-user processes. 2 pieces identified are the communication partners and quality of service. Everything is application specific in this layer, and it provides application services for file transfers, email, and other network software services. HTTP, FTP, POP, and SMTP are all protocols found at this layer. Layer number 6, the presentation layer, is responsible for the format of the data transferred during network communications. This layer handles the formatting and translation of data. It confirms the data is able to be read by the receiving system and transforms the data to the form the application layer can accept. This layer also formats and encrypts the data being sent across the network, helping provide freedom from compatibility problems.
Session, the 5th layer, establishes, maintains, and coordinates communication between applications across a network. Manages who can transmit data when and for how long. Examples of functions at this layer include domain name system, log-in log-off, and also checkpointing, which is the syncing of 2 related streams of data, like the audio of a video. The application, presentation, and session layers of the OSI model are all performed by just the application layer of the TCP/IP model. Layer 4, transport, ensures reliable delivery of data, breaks data into segments, handles sequencing and acknowledgements, and provides flow control.
Reliability is achieved through acknowledgements and flow control, ensuring the recipient is not overwhelmed with data. Large data streams are segmented to not exceed a particular networking technology's maximum transmission unit. Transport layer header fields include source and destination port numbers, sequence and acknowledgement numbers, and window size. Components working at this layer are transmission control protocol and user datagram protocol.
The network layer of the Open System Interconnection, or OSI model, routes the data from one location to another or across several defined networks. A network is a series of devices that are connected to a single physical medium or broadcast domain. A network represents interconnected devices moving signals between one another. The network layer moves data between these networks of interconnected devices, dubbed an internetwork. This can be done on a small scale, separating data on a network of a dozen computers, or on a large scale, separating data for an international corporation across the globe. The second level of the Open System Interconnection, or OSI model, is the data link layer. The data link layer is adjacent to the physical layer, so they are associated pretty closely together. Whereas the physical layer deals with the actual physical media, the data link layer deals with signaling or the method used to send data across that media. Part of sending signals across the network's media is coming up with a way to identify the sending and receiving devices. To solve this issue, networks use numeric identifiers, such as a MAC address associated with a network interface card. Every network card manufactured in the world has a globally unique MAC address associated with the card. To make identifying the MAC address easier for the end user, it is usually printed on the outside of the product box or on the outside of the computer when it is installed.
The physical layer is the first and lowest layer in the OSI model. The physical layer receives data from the data link layer. This layer is responsible for transmitting data by converting a signal from one form to another so it can be physically transmitted over a communication channel. Devices that operate at the physical layer include repeaters, hubs for connecting devices in a local area network, network interface cards, cables, and connectors.